In this video, we're going to determine what values of b make the matrix equation Ax equals b consistent, given specific information. So a and b are given below. So let's write it in augmented matrix form. Next, we're going to row reduce. And so we're going to take the first row and multiply it by 2 and add it to the second row. And take the first row, multiply it by -2 and add it to the third row. Next, we're going to multiply the second and third row by scalars. So for the second row, we'll multiply it by 1/10. For the third row, we'll multiply it by -1. Zero times 1/10 is 0, 10 times 1/10 is 1, 9 times 1/10 is 9/10, and then 2bi plus b2 times 1/10 will be 2bi plus b2 divided by 10. 0 times -1 is 0, -1 times -1 is 1, -2 times -1 is 2, and then we'll get 2b1 minus b3. Next, we'll multiply row 2 by -1 and add it to the third row. The first two rows stay the same. The third row changes. So -1 plus 1 is 0, -9/10 plus 2 is 11/10, and then we'll have 2b1 minus b3 minus 2b1 plus b2 divided by 10. Lastly, we'll multiply the third row by 10/11 in order to get this value as a 1. That way we'll have a 1 as the pivot position in each row. Next, we'll just multiply this entire quantity by 10/11. And so now every column has a pivot position of 1. So that means that there is a value for every b such that it satisfies the domain conditions of these values in this column, which is all reals. For our next problem, the values of a and b are given on screen, and now we're going to turn that into augmented matrix form. Now we're going to row reduce this, and we're going to multiply the first row by 2 and add it to the second row. So the first row stays the same, but we'll have 2 times 1 is 2, minus 2 is 0, 2 times 2 is 4, minus 4 is also 0, and we'll have 2 times b1 plus b2. And so now we need to figure out what values of b make this system consistent. And so we want to prioritize this bottom row here. Really, this is 0x1 plus 0x2 equals 2b1 plus b2, or 0 equals 2b1 plus b2. So let's think about what happens when 2b1 plus b2 equals 0. Let's write it like this. Equals 0. Then we'll have the matrix 1, 2, b1, 0, 0, 0. So then this matrix has infinitely many solutions. But what if this does not equal 0. Let's say does not equal 0. Well, then we'll have the matrix seen above, but we'll have 0 here and some number here. So this matrix would have no solution. So to answer our original question, what values of b make ax equals b consistent, well, we have solutions for the system when 2b1 plus b2 equals 0. And you could write this as b2 equals negative 2b1, but we'll only have solutions when this quantity here equals 0.